my name is Quay, Product Marketing from Advantech Industrial IoT Group, and also your host of the day. In today's wireless technology talk, we're going to share with you how to choose the right wireless technology for your environment and energy applications. In this discussion, it's my pleasure to invite two industry experts from Advantech US and Europe teams. First, let's welcome Andrew Lund, Product Sales Manager from Advantech US team. Hi, Andrew.
Hi, Quay. Thanks for having me on today. This is going to be fun. Just by means of introduction, as Quay said, I'm Andrew Lund. I've got maybe 10, 12 years of experience in the kind of wireless IoT space, although I think 10 years ago we called it more M2M and different things like that. But I have had the pleasure of working for Advantech for a few years now, covering both the US and Latin America, and I'm excited to be here.
Thank you, Andrew. And then let's welcome our second expert, Yuan Li, Product Sales Manager from Advantech Europe team.
Thanks, Quay. Hi, this is Yuan. I'm the Product Sales Manager of the Advantech Device and Connectivity Group in Europe. I'm responsible for industrial wireless solutions. My role is to set up and execute the go-to-market strategy for pan-European market, as well as supporting Advantech frontline sales and partners on their business development and project management. In addition, I'm deeply involved in the proof of concept project with customer for new applications and technologies, then feedback to our product development team. So nice to meet you here. Thank you.
Thank you both gentlemen. So in the following sessions, the audience will be learning 4 things. First of all, IoT industry attitude toward wireless technology. And the second one, a quick introduction of each wireless technology such as 5G, Wi-Fi, LoRa, and so on. Followed by a question, what is the best wireless technology and how to choose the most suitable one for our business? The final part, the most important part will be success stories around the world. Okay, that's back to the main topic. When we talk about wireless technology, the term 5G has been on the headline for a couple of years, which is said to be the next superstar among all wireless transmission technologies. Facing the 5G era, most of us would like to know if we should invest on 5G at the current stage or if there are other wireless technologies indeed more suitable for our business. To answer that question, basic understanding of all major wireless technologies is essential before making any investment decisions. So I would like to ask Yuan. You've been in the wireless industry for years, which is long enough to see the current scope of wireless technology for industrial applications. Could you please let us know, is wireless adoption really expanding in Europe?
Thanks, Quay. Yes, indeed, it is. In the past 5 years, wireless technology has been an important topic in the industrial marketplace. And during this time, we have not only seen a growth in request, but also a growth in adoption. Industrial 4.0, Internet of Things, factory digitalization, OEE monitoring, and etc. These are the hot topics nowadays in industry. The key objective is collecting data. The data which is valuable for optimizing workflow, saving costs, reducing downtime, and increasing efficiency. Wireless technology can be a perfect solution for infrastructure and collecting data. It has the advantage on the first one, saving overall engineering installation cost, because wireless coverage doesn't need physical cabling to each and every endpoint or machine that needs to be connected or monitored. Second, flexibility when future expansion is needed. A well-planned wireless deployment allows you to expand the infrastructure easily and quickly with zero downtime. The third one is mobility, of course. These are the 3 reasons why the interest and adoption has been growing. Thank you, Quay.
Okay, so from your observation, people do have confidence in wireless transmission and are willing to adopt it to their business. Can you further elaborate more about the main reasons for companies to prefer wireless technology?
Yeah, I think by using the wireless technology, you can minimize physical cabling and installation cost. and downtime associated with factory refurbishment. In addition, you can implement quickly and easily a small-scale proof of concept for evaluation, and then if designed correctly, roll it out into the production environment. For customer, wireless technologies can shorten the time frame for adopting industrial IoT with acceptable investment.
Awesome. So according to Vin's sharing, wireless technology brings advantages that wireless transmission cannot provide. If we search online, there are numerous wireless transmission methods from cellular, Wi-Fi, NB-IoT, Bluetooth, LoRa also. We all want to know what the best one is. This question is for you, Andrew. Is there really a best wireless technology?
Yes, whatever technology you buy from Advantech is the best. No, just kidding. Certainly there's not one size fits all. I was actually thinking about this, and you can take an example from everyday life that we all use multiple different kinds of wireless technology every day, right? So just for me, on my way into the office today, I made phone calls over LTE. When I was at home, I used Wi-Fi to check email. Now I'm sitting at my desk and I have a Bluetooth connected mouse. When I was waiting at the stoplight on my way in my car, there's a wireless sensing that's determining whether cars are present at the intersection and changing the lights. So there's all kinds of different wireless technologies, and primarily the trade-offs are related to coverage, cost, throughput, power consumption. And these are, there are real trade-offs, and so those are kind of the criteria by which people are evaluating wireless options in the industrial IoT and specifically the energy and environment space. And so on the table that I'm showing here, you'll see proprietary mesh technology from Advantech, LoRaWAN, Cat-M or narrowband IoT, LTE, higher category LTE, and then Wi-Fi. And so this maybe is a helpful slide that people can use to do some comparison along those fundamental criteria: cost, coverage, throughput, power consumption. Thanks, Gwen.
Thanks a lot, Andrew. So the answer to best wireless technology varies from application to application. That probably means we need to have understanding of each technology so as to make a best choice. Can you quickly introduce the key features or differences between these wireless technologies such as Wi-Fi, LoRa, 3G, 4G, and the others, please, Andrew?
Yeah, for sure. So, Koi, one of the things that I've done in the past is use this highway metaphor or imagery. So if you think of, and the reason I do this is because it's very easy to think about I hear all these terms and acronyms and so forth and get confused. And so I use the highway analogy to sort of simplify it. So when the cellular carriers develop their network, they invest in infrastructure, billing software, support, sales, all this, and they charge, just like when you get on a tollway, let's say, you pay a toll. It's cellular carriers' highway also has a toll, and that's the SIM card, right? You pay for your data usage. And so in the image I'm showing here, the center kind of highway, high-speed fast lane, if you will, is like high-speed LTE. And we all use that on our phones and tablets and so forth. Adjacent to that, there's another part of the cellular data highway that the carriers still operate, but it's more like a service road, okay? So this is where you see technology like narrowband IoT, LTE category M. This is still a SIM-based technology. You still pay to use the highway, if you will, but it's much lower speed, much lower power, and it can be really keen for IoT applications. On the right side of this image is something that's not SIM-based. I call it like a bike path or a pedestrian path, maybe. It doesn't require a SIM card. It's not part of the carrier's highway, but it's still very useful for some low power, LoRaWAN, proprietary mesh, even Wi-Fi would be considered part of this highway. So between the previous slide comparing the different speed and throughput and power consumption elements, And then this sort of highway metaphor, I hope that our audience members get a picture of where each technology kind of fits and some of the relative trade-offs.
Okay, so I would like to ask, how about 5G? We've heard a lot of it from tons of articles or videos. Can you also provide us the short introduction of 5G and let us know what applications can benefit most from it?
Sure. Yeah, so it's interesting because as consumers, we're presented with a picture of 5G that's fairly monolithic, or kind of like just 5G. And the reality is that there are 3 specific use cases within 5G. Okay, and the slide that I'm showing now spells this out. So I'll just work through this real quickly. So, and by the way, it's very helpful. It's common, and I bet Ewan has the same experience, that customers come and ask, well, do you have 5G? And when they ask that, they're really meaning like, do you have just high speed, the latest and greatest high speed LTE?
Yeah.
So the use cases that I would share are critical communications. That means ultra low latency. Think about that for like smart cars, okay? And that's relatively far out. Okay, that's maybe, there are pilots going on now and so forth, but that's more like a 2023 timeframe. There's enhanced mobile broadband, okay, which think of like high-speed internet for humans, right? People streaming videos and replacing their home internet connection. That's a definite use case for 5G, and that's what most of the consumer-focused marketing is for. And then on the bottom here, which is something that's available today, is kind of massive IoT or low power, low cost IoT for remote sensing. And so that's available now. That's really, think about narrowband IoT, LTE category M. Those are really kind of part of the 5G use case definition, and it's available today. So that's kind of how I would kind of break down 5G for people. Is don't think of it just as a monolithic one, like you said earlier, one size fits all, but the 3 separate use cases.
Okay, thank you once again, Andrew. So in short, you said 5G is the 5th generation of wireless technology, and there are 3 significant features: high bandwidth, low latency, and high device capacity. So if the audience, your application relies a lot on bandwidth, or it is time critical, or you have less amount of devices, 5G perhaps will be your solution. We've went through pretty much about technology, and now I would like to talk a little bit more about applications. Researchers tell us that wireless transmission is best for wide open space that need long transmission distance, or areas where wire deployment is hard to reach. Environment and energy market is a very good example. What is the most important factor or character for selecting a wireless technology for environment and energy applications? I hope Yuan and Andrew, both of you, can share with us.
Thanks, Wei. Andrew, I think I will go first. From my point of view, the most important factor is geographical coverage, or let's say transmission distance, because most of the applications in energy environments vertical markets are wide distributed. The entire measuring points or connection points in single wide system is usually required to cover from 100 squares of meters to 100 squares of kilometers, and even for nationwide coverage. The wireless technology which take advantage in these vertical markets are serial technology, and of course the LP1 technology like narrowband IoT, LoRa, and Sigfox. However, there are also other concern factors depends on different application scenarios, such as security, airtime cost, time sensitivity, and national regulations. Thank you. Great.
Yeah. And just to tack onto that, Ewan, I think maybe some examples to tie that specifically to E&E customers, and some of the like hot topics that you see in the news. I think about climate change. So for example, we have customers in the US in places like California, which are prone to wildfires because of rising temperatures, diminished precipitation, and so they have meteorological applications measuring essentially the risk for wildfire based on climate change, and they're using LTE technology to do that. Hot topics like security. So recently we had a major hack in the United States with a major retailer, Target, that was ultimately traced back to some access that was provided to an HVAC contractor. So now we work with HVAC contractors to use LoRaWAN and bring in their own network completely separate of the retailer. Think about emerging markets, like for me and specifically in Latin America, they're modernizing their grid. They deal with non-technical loss, another way of saying people stealing electricity in some cases. And so they're modernizing their grid using LTE, going straight from 2G or wired connections straight to LTE. It's got to be very cost optimized. Predictive maintenance, and I think I'll show a slide maybe later, Quay, showing how people are using LTE combined with really high power, big data type of applications to monitor compressors on natural gas distribution lines. So there's a lot of examples even within the E&E space of this technology being used.
Thanks for your sharing, gentlemen. So we've learned the differences between wireless technologies and some important factors that we should put into consideration when choosing among them. As I myself work in the marketing team, I often receive feedbacks from readers that theory is just theory. How to do it is the most important thing that they care about. Trust, there must be some success cases in both US or EU markets that you handled. Can both of you name a few cases to share with our audience? Perhaps the audience can leverage your experience to succeed as well.
Yeah, I would like to share my first case studies. This first case studies concerns the water supply industry. Water is very critical to society, and the water utility companies own and operate both the supply, reservoirs, dams, river, and streams. Additionally, they are also responsible for water quality and safety and the impact on environment, management of wastewater, be it residential, agriculture, or drainage. By extension, any monitoring system used needs to be robust, reliable, and flexible. Our case study focuses on deployment of Advantech wireless LTE solutions to provide pump stations, wastewater monitoring, and metering, while this providing a stable, secure, and reliable wireless communication. Some of the critical challenges we faced are the first one, reliability of communication. Loss of communication to control system is simply unacceptable. For water meter readings and the data provided must be trusted by both consumer and also the water company and have guaranteed delivery. The second is infrastructure. The water company's physical monitoring equipment may be based on earlier generation OT equipment. And the third one is the flexibility, the ability to add new monitoring equipment without downtime. The most critical decision was what type of communication infrastructure to use. Wireless was chosen as it offered many benefits such as ease of installation, flexibility, and implementation time. For the type of wireless technology to be used, there are several factors governing the decision. The first one, signal penetration becomes a key factor because most of the control system and meters are installed in built-out areas, basements, or in buildings. The second is distance. Lower frequency wireless technology allows the user install wireless node much further away from the provider base stations, so eliminating the risk of poor coverage. The third one is security. Security is very critical. The data being carried over the wireless network must be encrypted, so preventing data theft, corruption, or unauthorized access to the network. And the last one is legacy support, because control and monitoring equipment in use may support older non-IP based industrial protocols, such as Modbus RTU. Conversion of these protocols to modern IP based technology is critical to reduce cost. The decision for this project was made to deploy LTE-M technology, a low-power wide area network wireless technology developed by 3GPP and targeting machine-to-machine connectivity and Internet of Things applications. LTE-M has many advantages for this application, such as signal penetration, distance, encryption, and because being a 3GPP standard guaranteed the interoperability with the service provider's wireless network. To provide the wireless communication, the Advantech ICR3211 LTE-M router was selected. As a standard, the units come with Ethernet interfaces and serial ports to support legacy non-IP protocols like Modbus RTU, and conversion to IP-based protocol. In this case, it's Modbus TCP. Additionally, the ICR3211 support VPN tunnel for guaranteed data security and optional custom application modules to provide extra functionality and data handling for edge intelligence. For water stations monitoring, an LTE-M lightweight data acquisition device was specified. The WISE LTE-M module, a rugged unit designed for challenging environments and offering a rechargeable battery designed for situations where power may not be available. This device has the advantage not only of integrated sensor interfaces such as a pulse input or M-bus input, but also supported periodically data reporting by lightweight IoT protocol, especially with the TLS to securing the connection. Compared to controller or consumer monitoring, the volume of the water is massive. Optimizing the data transmission airtime cost become a very important decision point and discussion point. In this project, Advantech worked with the customer control engineers to specify not only the optimal wireless technology for this application, but also a best-of-class IoT solution architecture for bridging OT, IT, and telecom all together with great ROI. So that is my first case studies. And I would like to also share another case studies. And the second case study I would like to share is for electricity grid monitoring and management. A European-based distribution system operator, a DSO, who has implemented a large-scale deployment of Advantech smart wireless LTE routers for substation communication. For the electricity grid operators, the demands being placed on them by their customers, suppliers, and regulators are becoming more challenging. Reducing pollutions, increasing the use of renewable energy sources, the growth in electricity vehicle usage, and finally, reduce their own energy consumption. These new demands and expectations are forcing those DSOs to invest more in automation and monitor of their distribution grid. The upgrades taking place to the grid monitoring and management system are designed to ensure resilience and reliability, while it's balancing generation and demand. Part of infrastructure necessary to support such automation and control is wide area communication system to link together the critical points of their grid. Advantech ourselves has recently provided a complete grid monitoring communication solutions for a major DSO. The solution we supply ensure high reliability, easy expansion, security, simple installation, and critically scalability. Also, the ability to roll out hundreds, even thousands of systems as easy as the first time. The challenge from the DSO was they needed to upgrade their existing telecommunication infrastructure to reflect the demands placed on electrical grid, ensure high reliability communication to various substations, switching stations, interconnections site for every site, and also distribution locations. Initially, the project was for 1,000 remote sites, but plans exist to grow these from 1,000 to 5,000 sites over the next decade. A major decisions on whether to use a wire or cellular LTE communications was taken. Many of sites are identified for connections are remote. A wire connection would be too expensive, difficult to implement and to maintain. It was therefore decided to deploy a fully wired solution, and availability would be very critical. The wireless solutions needed to offer a high degree of resilience, and in addition, specific high priority sites, for example, like the switching stations and the substations, require even greater availability. When operational, the whole system needed to be monitored to ensure system performance and availability. And of course, security is also paramount. The communication solution would need to support a class-leading robust cybersecurity protocol that would protect the network and conform to the most stringent security audits for critical infrastructure. Lastly, there was the major issues of installation and provisioning. The solution had to be simple and easy for their field engineers to install without any special training on device configuration or commissioning. In this project, 3 different Advantech wireless LTE routers were deployed to provide the connectivity for grid monitoring. For the highest priority location, an Advantech Smart Motion router would be used, offering dual simultaneous cellular connections from 2 different providers with 2 different SIMs. This would ensure the highest possibility availability. Additionally, in the unlikely event of a total failure of cellular connectivity, a wired satellite connection was also deployed at these high-priority sites to provide a backup or fail-safe link. Smart Motion routers would provide 3 different communication paths to central monitoring site. For the low-priority site, and depending on the physical connections to local monitoring system, either a Smart Star router or a Smart Flex router would be deployed, offering 1 active cellular connection, but again, utilizing the new SIM cards to allow failover to the backup operator in case of availability issues with the primary operator. Ensuring the physical communication was one challenge, but bigger challenge were security, monitoring, managing, and provisioning the network. Each physical site would communicate via dual encrypted links with 2 central management sites. To solve this challenge, Advantech we also proposed the WebAccess DMP, our provisioning applications, which simplifies the installation procedures by supporting a zero-touch provisioning system with automatically linking the router on the first power up to our central management system. This would avoid any need for configuration on site, minimize human errors, and therefore would speed up and lower installation costs. Additionally, provisioning is an ongoing challenge when the control system at the substations may be upgraded. Many new protocol conversions that may have to be deployed. WebAccess DMP allows the DSO to easily push out new functionality to the installed routers. WebAccess DMP offers a full suite of deployment and management tools, such as a zero-touch deployment, site-specific configuration, and an additional layer of the monitoring and diagnostic. Our customer trusts Advantech to provide both a resilient and secure wireless communication network. Advantech's proposal helped them roll out a communication system into 1,000 substations over the course of a year without a hitch, proving the value of the simplifying installation process. So far, the project is still ongoing, and we are now continuing to deliver our LTE routers to this customer. Yeah, so this is my second case study. Thanks, Quay.
That's good. Yeah, thanks, Ewan. Yeah, so Quay, I have a couple that I can share. I'll be quite a bit more brief because I know we want to get to kind of talking about a few of the Advantech solutions. But in the U.S. we have, and it's pretty common throughout the world, natural gas distribution pipelines, and you can think of them as networks. And one of the examples I would share specifically for the energy and environment space was with a customer called Windrock, which is at the time it was part of Dover Corporation. You can Google Dover Windrock and you see the solution they put together. But what I'm showing now is a single slide to sort of capture some of the key aspects of this success story, if you will. Okay, so on these natural gas pipelines, unlike water, from Ewan's example, natural gas doesn't just flow by gravity, right? It has to be compressed and pressurized to flow through the system. And so periodically on a natural gas pipeline, there are compressor stations, and you wouldn't recognize them. They're just usually housed in a nondescript building, but inside that building there are giant compressors, turbines, I guess, basically spinning and creating pressure to push that gas through the pipeline. Okay, you can imagine then that with these compressors spinning all day, every day, throughout the year, irrespective of temperature, moisture, whatever, there's a significant amount of wear and tear, and the opportunity for predictive maintenance is pretty appealing. So the Windrock solution is to fundamentally monitor 360 points on that revolution of that turbine, and then collect data, 360 data points per revolution. So you can imagine this is a really massive amount of data, and also it's in an area that's exposed to natural gas fumes, and so it's a very hazardous environment. What the Windrock solution does, and you can see an image of this on the top right of the slide here. They've got a specialized controller and cabling and a sensor that they've developed that goes on each of these compressors, but they need a way to send that data fundamentally to their Windrock application, which is a very complex, data analysis and presentation application for predictive maintenance. They need to send that data from the controller over the LTE network to Azure, and then their application goes and gets the data from Azure. So if you think about all that's going on in that application, you need a way to do Python development and you need a way to do Azure interface or integration, which we accomplish through Python. You need to be able to work across all different carriers in North America. This is maybe a challenge that can be unique to North America. We have our carriers. One SIM doesn't necessarily work on all carriers, right? So the ability to flex across carriers, depending on who has the best coverage in a given location, the ability to work in a hazardous environment, Class 1, Div 2, and ATEC certification, and then really high temperature ratings. Most Wi-Fi radios start to degrade, and LTE, frankly, start to degrade pretty quickly at high temperature. In this case, the SmartFlex was not only just a perfect product, but with all the supporting certifications and development support for this application. Again, just to kind of keep it going here, I would share another example, and Ewan mentioned LTE Category M. We talked about that a little bit as one of the 5G use cases. What I'm showing here on this slide is a customer who is responsible for managing elevator and escalator operation. Most of their business today is in the greater New York City area, but fundamentally their New York City Public Housing Authority and other customers of theirs wants to know, hey, they want to know if an elevator is stuck between floors, if the door is stuck open, if the door is stuck closed, what's happening at that elevator. And so it's accomplished by using an ICR, this is an LTE Category M product from Advantech, connected to the lift controller, and I show some pictures here on the slide, basically making an RS-232 connection and using a Python script to read Modbus registers, send the data up to, I believe they use AWS, doesn't matter, to send it up to the cloud, to an MQTT broker, and then to the web application. Now, special, earlier I talked about one of the trade-offs for, and you talked about this too, one of the trade-offs or one of the evaluation metrics being coverage and then power consumption. So LTE Cat-M has quite good coverage, or let's just say like data transmission kind of persistency. So it's able to communicate to bunkered locations that are surrounded by brick and metal, like an elevator or escalator control room or control pit for an escalator. And then this particular product has a little super capacitor built in for about 30 seconds of, we call it like a last gasp message, right? So if power's lost, it'll send a message saying, hey, I lost power, here's my status. That's very helpful if you're using a web application and you see, hey, I don't have any communication with my remote asset. Why is that? Is the network down? Is the power lost? This helps solve that problem. So yeah, I guess that's four examples from us, Quay. I hope we didn't take too much time, but they're pretty good examples. Thanks.
I like your examples. Yuan, I like the example how you mentioned web access, DMP, right? It's about provisioning. I like the idea of provisioning, managing a mass amount of routers, and I also like Andrew, your case, the company is called Windrock, right? Windrock case. I also like that case. And it looks like that both of you do have several success stories to share with us. Perhaps today we don't have enough time. Next time we'll invite you again to talk more about that. Okay, now, as everybody knows, Advantech has been in the industry for about 36 years, and we do provide plenty of solutions designed for each specific application. I would like to ask you two gentlemen again, Yuan and Andrew, can you recommend our audience some of our solutions that are most welcomed and most widely adopted, please?
Yeah, I think Advantech, as a leading industrial solution manufacturer, and are the only companies who can offer a comprehensive product portfolio with multiple wireless technologies for industrial applications. From the most popular wireless technologies such as Wi-Fi, LTE, RFID, Bluetooth, to the latest wireless technologies like NB-IoT, LTE, LoRa, and of course for the future 5G new radio. Wireless technology is often viewed as an IT technology by the industrial customers. As a company with an integrated portfolio of wireless solutions, we would like to help our customers understand the various technologies and how they can provide solutions to solve their problems for both today and of course for the future. The most common questions we heard are how can we utilize this technology for our OT system to maximize efficiency with a good ROI? The Advantech vision is to offer best-in-class wireless solutions to industrial markets, which are easy to implement, offer a high degree of flexibility, and finally, be cost-effective.
Yeah, and what I would add to that, speaking specifically about products, Quay and Yuan, think about the flexibility element and how important it is to be, like we said, one size doesn't fit all. I would, and I think I have a slide I can show here, showing our WISE 4000 product series, and really our WISE line in general, that's supporting a lot of the technologies we've already talked about: LoRaWAN, LTE-M, narrowband, Wi-Fi, some proprietary low-power WAN technology from Advantech. It's a really valuable product, both for supporting those technologies and then for having the flexibility to use different kinds of I/O combinations, serial combinations, connector options, battery backup, GPS, and so forth. So a lot of different options within the WISE family of wireless sensing products. And then maybe second to that, where I would point someone to learn about Advantech solutions in this area, is the area of our industrial cellular routers. So we're one of the top providers of this category of product, industrial cellular routers, globally. The ICR 3200 series of LTE gateways, extremely high performance, and what's very important about these, and we've kind of mentioned it a little bit through our stories, what's important is the ability to do a little bit of edge computing, a little bit of legacy protocol conversion, custom scripting, things like that at the edge to make them more than just a modem or more than just a network appliance. That ability to do customization at the edge is really important. But of course, they are actually network appliances as well, right? So web access device management platform, web access VPN, these are really powerful, established, affordable, by the way, software packages that help customers deploy, maintain, and manage multiple devices in the field in a secure, reliable way. So, and as Ewan alluded to, in 2020, we're going to be launching our first 5G industrial gateway. So we'll be one of the front runners in that space too. So.
Okay, thanks a lot for your introduction, Andrew and Yun. So during the past 1 hour meeting, I would like to have a quick recap of what we talked about today. First, we talked about wireless technology is for sure widely accepted and applied in several applications such as environment, energy, or transportation that Yun just told us. And then these applications share one thing in common: wide area that requires long transmission distance, yet wire deployment is not really feasible for this area. If you, the audience, are asking what the best wireless technology is, the answer from Andrew is there's no standard answer because it all depends on your applications. 3G LTE, Wi-Fi, LoRa, these technologies have their own strengths and benefits. If you need two experts here to help you sort out your application needs and the corresponding suitable wireless technology along with Advantech TECH Solutions, don't hesitate to contact us, these two gentlemen. So this brings us to the end of this wireless technology talk. Hope you do learn something from this episode. Thank you once again, Andrew and Yuan, for your sharing today. I really like your sharing, especially the case studies, because that inspire people how to leverage the power of wireless technology on their environment and energy business.
Thank you. Thank you.
Okay, thank you.
Bye-bye.
And don't forget, no, not yet, bye-bye. Don't forget to subscribe Advantech channel for latest technology and transferring just like what we do right now. And let us know what you want to know by leaving a message down below in the comment box. So, okay, it's time for bye-bye. See you next time.
See you. Thank you.
Bye-bye.
Bye-bye.
Bye.